Good morning, everybody. Today I reveal the truth of dimension. Here in physics, dimension is nothing but the power raised upon the symbolical form of fundamental unit. Symbolical form means or mass M A S mass. It is M. For length it is L. For time it is T. Thus, the power raised upon the symbolical form. When we write the unit of any physical quantity, here dimension says how many times of the fundamental unit or fundamental thing is associated with the physical thing like velocity, acceleration, force, etc. Therefore, we see dimension of energy is ml squared t inverse 2. It means m 1 times, l 2 times, and t 2 times inversely involved in this. We see the dimension of distance L because it is length, displacement also length but in certain direction L, dimension of speed it is LT inverse, dimension of velocity LT inverse also, dimension of acceleration LT inverse 2 because here change in velocity by time. Time comes in 2 times inversely. So here length 1 time and time 2 times here. Similarly, we see in 6 force MLT inverse 2, work done ML square T inverse 2, power ML square T inverse 3, momentum ML T inverse, impulse ML T inverse, pressure ML inverse 3, here it is hidden L minus 3. Next, we are all acquainted with the dimension. What is dimension? Now, why we read the dimension? Why we study the dimension? What is its need? The dimension here basically 3 uses: to check the physical formula, the conversion of system of unit from one system to the other system to establish the simple physical formula. We use three types of dimension. The conversion of the system of unit from one system to the other system. Here we see the example about the dimension, use of dimension, the conversion of Newton SI system into dyne. It is unit of force. In MKS system or SI system, force of unit is Newton and dyne. Now, here the numerical value in SI system N1, numerical value in CGS system dyne, I mean others different. The values should be same. Therefore, N1 U1, U1 per unit in MKS system, N2 U2, N1 N2 is the numerical value. Here at the place of unit, we put here dimension D1, D2, D1, D2. Now we have to find here question marks. Okay, how many 1 Newton is equal to how many dynes? Question mark. We have to find the question marks. At the place of question mark, we see it is N2. So we have to find the value of N2. The N2 becomes here N2 is equal to N1 D1 by D2. Okay. Now D1 for SI air force, this will be M L T inverse 2. This is the dimension of force. Also dyne, in dyne or in Newton. In Newton, in one system, we write here 1, 1, 1, M1, L1, T1 inverse 2. So, D1 is upper portion, therefore M1, L2, T1 inverse 2 in upper portion. D2 is lower portion. So, for dyne, we write the same dimension M2, L2, T2. The M2, L2, T2 inverse 2. On putting these value, we have the equation like this. Now, at the SI system, M1 value kg, L1 value meter, T1 value second. In CGS system, the mass M2 is in gram, L2 is in centimeter, and time T2 also in second. Time remains the same in any system of unit. Now we put the same, and after putting this value at the place of kg 1000 gram, at the place of meter 100 centimeter, and second remains the same. Therefore, after computing this, we shall get 1000 into 100 means 10 to the power 5 Newton. Thus, we see the conversion of Newton into dyne. It means 1 Newton is equal to 10 to the power 5 dyne. Here it is written, it is wrong. Here we have to write here dyne. So 10 to the power 5 dyne. Okay. At the place of Newton we put here dyne. Okay. Now there is limitation of dimension. Dimension cannot fly or long and long. It has also dimension. What is the limit of the dimension? The limit of dimension, constant term has no dimension. Angle, because it is the ratio of the same thing, length by length, perpendicular by hypotenuse, or also arc by radius, length by length. So it has no dimension. Trigonometrical ratio also has no dimension. Sin theta, cos theta, tan theta has no dimension. In addition and subtraction, dimension remains the same. Addition or subtraction, dimension remains the same. There is no change in dimension. The ratio of same physical quantity has no dimension. Now, let us establish the formula on the basis of dimension. Here, we establish the formula related to the time period of simple pendulum. In simple pendulum, there is effective length L and gravitational acts upon the bob of the simple pendulum. When the bob of the simple pendulum slightly displaced from its mean position and then release, we shall find that it swings. It has to and fro motion about its mean position. The repetition of the same. Then we have to establish the relation among time period T gravitational acceleration mass L. For the homogeneity of the dimension, the both type side dimensions should be equal. Here we want to establish the relation among them, then T varies L to the power x, m to the power y, g to the power z. X, y, z arbitrary constant. Now we at the place of proportion sign we put k, proportion constant, and k has no any dimension. It is dimensionless quantity. On putting the dimension, we shall find that in LHS and RHS, the dimension of all similar thing like mass, like length, like time will be equal. Therefore, equating the powers from both the sides, we have at the place of here m is equal to 0, m to the power 0, here in right side m to the power y, therefore 0 is equal to y. In left side l to the power 0 and l to the power x plus x, or this is z, x plus z, x plus z is 0. Now e to the power minus 2x, minus 2z, it is z, not x. So minus 2z is equal to here 1, because power of t is 1. Therefore z is equal to minus half. On putting the formula in this, we shall get x is equal to half. Now we put the value of x is equal to half, z is equal to minus half, y is equal to 0 in this formula. We shall get t is equal to k l to the power half, g to the power minus half, which will go in denominator. Therefore, the value of time period becomes t is equal to k l to the power half, g to the power half. It means t is equal to k under root l by g. Here, if we go in deeper, we shall find the value of k also. Practically, its value is 2 pi. The final value will be t is equal to 2 pi under root L by G. This will be the value. Therefore, with the help of dimension, we shall find the simple physical formula. Now, with the help of dimension, we also check the formula if it is correct or not, right or wrong. Here, we check popular formula. S is equal to ut plus half at square. In left hand side, dimension of S is L. In right side, dimension, total dimension, is also comes to L, because the value of constant has no dimension. So the dimension of LHS and dimension of RHS becomes equal. Therefore, the given formula is correct. Then with the help of dimension, we can check the formula of simple formula, it is correct or not. And also we establish the formula. This is the use of dimension. Okay. Here there is something wrong. Here we have written Newton. Here should be dyne, not Newton. At last. Thank you.